All right, okay. Uh, the said charges minus 4 nanocoulomb is at origin, and a charge of plus 6 nanocoulomb is at 8.0 meters from the origin. I say, what is okay? Let's say find the electric field at point. What is the E at point 1.2 meters from the origin? Everything is along the x axis. So how do we do this? First, you draw the x axis. You draw the x axis. So that x axis I draw is too much. Let me redraw this x axis again. Just draw the x axis. Then you draw y axis. The point in which the x meets the y axis is called the origin. So you can just choose any origin. You can choose any place to be your origin, anywhere at all. I can just say, okay, since everything is moving to the plus, remember this side is minus, this other side is plus for x. So this plus x, side is minus x. So since all the distance are just positive, there's no negative distance. Because negative distance is going to come to the left side, positive distance going to the right side. So see that all the distance are just something like positive, so that means I'm going towards the positive direction. So I can just put my origin here now. So here's the origin. That's where x and y will meet. So the next thing I will do now, I'll put my minus 4 nanocoulomb here at the origin. And I will measure, you can just use your eye gauge to measure 0.8. Measure 0.8. This one now is 0.8 meters. Then you put your plus 6 nanocoulomb there. Then you measure 1.2 from this origin. 1.2 now is more than 0.8, so it will be somewhere here. I say, what is the electric field at this point? What is the electric field at that point? So we have two charges now. We have a charge here. We have a charge at this point. Then we have another charge at this point. So those are the two charges we are having. So taking note of that is very, very, very important. So we have a charge here. Then we have another one here. Now the one we have here is negative, while the one we have here is positive. So for you to get the direction of this electric field at this point now, we're looking at electric field at that point, due to this minus 4 and plus 6. So the first thing I'm going to do now, you just consider the field lines from each of the charges to this point. So we'll draw a line just like this. Just draw a line. Assuming, okay, let's just assume. Let's assume this line was done here. And this one was done here. Let's assume that. That'll be better. As those two lines were not there. What I'm trying to say is that the first thing you do, you draw a line to this point, where that is from each of the charges. So draw a line from here to until you get to this E, something like that. The next thing you will check this line you are drawing from each of these two charges now. Then you now check this electric field here. Will it leave a positive charge or enter a positive charge? Will it leave a negative charge or enter a negative charge? Now there's one property of electric field lines is that they will enter negative charge, or they are directed towards a negative charge, and they are always directed away from a positive charge. They are leaving a positive charge. So if the line is positive, they will be leaving. So this one will be, so for positive charge now, the field lines will be leaving. We're taking note of that. Field lines will be leaving for this positive 6. Then for negative charge, the field lines will be entering the negative charge. So that's how it is done. So let me just draw it in a way that you grab it perfectly. Look at what I'm trying to say. So just get this drawing we brought out from the question. So look at what I'm trying to explain now. What I'm just trying to explain. What we're able to bring out from the question, the drawing we're able to bring out from the question let me just first set this ink so the ink would not be too much. Was that we had a charge at the origin which was -4. We had another charge at somewhere here which was +6. And so what is the electric field at somewhere here, this point, where the electric field at this point. So this charge was negative while this one was positive. And I said the first thing you are going to do is to get the direction of this field here. What is the direction of that field there? To get the direction, just draw a field line from each of the charges to that point. So for positive charge, the field lines will be leaving the positive charge. So that is the direction of that field lines. It's leaving the positive charge. Then the second one, which is -4, just also draw a field line from this place until you get to this same point. For negative charge, the field lines will be entering a negative charge. Field lines are always coming towards a negative charge and they are moving away from a positive charge. So reference to this place, so just draw a field line to that point in which you are looking for the electric field. Then if it is positive charge, for example, now let me just for example, let's say what is the electric field at this point due to this charge, let's say plus. We just draw a field line to this point, electric field lines will be leaving a positive charge. For example, now assuming the charge was negative, we just draw a field line to that point, the electric will be entering the negative charge. Simple as ABCD. So we are done with that. So the next thing is to get the distance between each charges and the field. What is the distance between this and this field? What is the distance between this and this field? That's the next thing. Get the distance between each charge and this field. We already know that from origin to this point, they said it's 1.2 meters. From the question, from here to this point is 1.2. Then we said from here to here was what? 0.8 meters. If the full distance is 1.2 and from here to here 0.8, which is now from here to here, will be 1.2 minus 0.8. 1.2 minus 0, that is 0.4. That should be 0.4. So from here to here now will be 0.4 meters. So you also take note of that. It's very, very important. So I'm done with this drawing. So let me just clear it up. Just clear this one up. I'm done with this one. So the next thing you're going to do now is to calculate the electric field due to this -4 and due to this +6 and add the two together vectorially. So I'll call this one electric field due to this first charge. I'll call this other one electric field due to the second one. This one is electric field due to the 4. That is electric field due to the 2. So the total electric field at this point now, total electric field at this point will be, anyone go to the left, you take negative sign. Anyone go to the right, you take positive. That's why I go to the left. So that's a left. Left means it's negative because in the left hand side of the x-axis you have negative stuff there. Then anyone go to the one towards the right will be positive E2. So we can that will work. When we are doing resolution of forces, the left hand side for x-axis is negative while the right hand side is positive. So this will give us the total electric field. This is what we are looking for actually. So that's how it is done. So what you just need to calculate E1, E2, then you just solve it this way. What is E1? What is E2? Remember, E is K cube R squared. K cube R squared. So from here now you can get this stuff out. So let me clear the drawing since we already gotten what we are looking for. I hope you know how we got this. E1 is going to the left hand side. It's negative. It's not because it's pointing towards the negative charge, no, because it's coming to the left. You should do your left or your right. The E2 is pointing towards the right. That's why that one is positive. So from here, okay, let me just clean this part off. Let me clear this part again. I'm done with this drawing. But you should know the value of E1, E2. I'm not done with the drawing. No, because we have distance between the 4 and the charge, distance between the 6 and the charge. We're also going to be using it. Let's just do it one after the other. Okay, this is how we are going to add. So what is E1? E1 will be KQ1 over R squared is the arrow 1. K is 9 times 10 to the power 9 is Coulomb constant. Then Q1 is -4. But since the negative have already showed us the direction of the feed line, we are not going to include it in this place again. So we already used the negative sign to denote the direction of the feed line. So just take the value of the absolute value of the charge without any sign. So we just take 4 times 10 to the power minus 9, because 4 nanocoulomb is minus 4 times 10 to the power minus 9 coulomb. Because nano means 10 to the power minus 9. If you want to solve, no matter we have analyzed the direction already, don't go and include the sign again. So that's what I'm trying to. So please take note of that. It's very, very important. You just watch other videos we have been doing, you will get it properly. So from here now, we will be having something like divided by, what is the difference between this 4 and this feed? We said it's 1.2. Was given in the question. Between the origin and the feed is 1.2. So 1.2, then you square it. So what will be the value for E1? What will be the value for that E1? Then you get the value out. The same way you calculate for E2. Okay, let's not get the value of this E1 out. Forget the value of that E1 out. So this is going to give us 25 Newton per coulomb as E1. So E1 is 25. Take note of that. Okay, let's get E2 now. Let's get E2. The same way for E2. Already feed due to the second charge. That's what we are looking at. So the feed due to the second charge is going to be K times the second charge divided by the arrow squared. Arrow between this 6 and the feed. What is the distance between the feed and the feed? We said is the full distance minus this 1.8, which is from here to here. So we're going to have K is 9 times 10 to the power 9 times Q2 is 6. Remember I tell you don't add the sign. 10 to the power minus 9. Because nano means, this nano means 10 to the power minus 9. That's why you are showing it. Because nano, that's why I see 10 to the power minus 9 there. Please take note of that. Is very, very important. The next, divided by, we said the distance between this 6 and this field is 0.24. Also subtracted 0.8 from 0.8 from 1.2, we got this. So if you solve this, this will give us 337.5. So I'm going to get from this other one. So E2 is equal to this. E2 is 337.5. So we take note of that. So what will be the total now? Remember we said total is we said the total. We already said the total is minus E1 plus E2. Because E2 is leaving this positive charge and it was pointed towards the right. Then E1 is entering the negative charge. It was pointed towards the left. So we have minus 25 plus 337.5. So minus 25 plus that, what I'm going to have. So we are going to have 312.5 18 per coulomb. So this is the answer to the problem. Unless there is any typographical error analysis. So just this is how it is done. So it is done. Just before analyze everything, before you know it, you are going to get this. So let me quickly just run through everything again so that you will get it properly. Quickly just run through everything again. So what I say you should do, I said the first thing, I said charges minus origin. Just draw your S axis. Just draw out your S axis, mark out origin. Put minus 4 there. Then measure your 0.8. Put plus 6 there. Then measure from origin as well, 1.2. Put your electric field there. The next thing, this one is positive. But why this one is what? Negative. For negative, electric field will be coming into the negative charge. For positive, electric field will be leaving. because we're looking at the electric field at this point. So we are taking it from this point. So if you want to check this one now to this point, you call that the thing will be leaving. If you want to check this chart to that point, that will be coming into this particular place. So this one now is E1 and it's negative because it's coming to the left. This one is E2 and it's positive because it goes to the right. Next thing, to find the total now, total will be minus E1 plus E2. Then the next thing we're going to do now is calculate the value of E1, which is KQ over their distance squared. From here to here is 0.8. Right, so 0.8. What will you add to 0.8 to make the full distance, which is 1.2? 0.4. Or just remove 0.8 from the full distance, which is 1.2, that's 0.4. So between 6 and E now is 0.4. Between minus 4 and E is already 1.2. From there, you calculate using KQ over rho squared for both of them. This one now, if you want to do K is already 9 exponential 9. Arrow for this 4 is from here to here. From this place to this place is arrow for 4, which is 1.2. Put 1.2 square here. Then Q is 4. Don't use sign. See, already use sign to get direction. Just do now is 10 to the power minus 9. Just 4 times 10 to the power minus 9. Put it here. You're already good to go. The same formula apply for this plus 6. Put plus 6 here. Then put this distance 0.4 here. Then you get it. Then you just find everything like this. Then you get this. So thank you. Subscribe and share, then like. You're blessed.